Let's now see next application of references. The next application is in range-based for loops. Range-based for loops are used to traverse through a container. The container can be an array, it can be a vector, can be a string, or other containers that we will study in the standard template library. So when you are traversing through a container, there are multiple ways of traversal, and range-based for loop is super easy to write. For example, if I want to traverse through an array, I can just write the array name, and the same syntax can be used for a string, vector, and other containers. I can write the container name right after the colon, and before the colon I can write the type of elements inside the container. Here it's an array of integers, so I've written index. You can also use auto here. Auto is typically used here just to not to remember all the complex types when you especially use standard template library, right? So you can simply write the auto x here and then colon, then container name, and you can traverse through all the items of the container. Now what happens in this range-based for loop is, when you traverse this way, this x contains a copy of every item one by one. And since it contains copy of every item one by one, we have the same problems as we had in function parameter passing. We cannot change the original elements because x is a copy. If you make a change to x, the changes are not reflected in the original array. See, I made x equal to x into 2 and then I printed the array again. So what happens now? I get the original array. I don't see the changes happening in the original array. This is one problem as was there in the function parameter passing. The second problem is performance issues. If your container contains large elements, for example, if you have an array of strings, what will happen? Every string will be copied to the string variable s one by one, right? Which is a performance problem. And if we are traversing the array of strings this way, then first this will be copied to s, then this will be copied, then this will be copied, right? So these two problems can be solved with the help of references again. Here are the modified codes. In this code, I have put reference here simply. With the help of this reference, now if I change make any change to variable x, the changes would reflect in the original elements also. Because now x is not referring to another location, it's not a label to another location which contains copy of every element one by one. X is labeled to same location one by one. X is first a label to this, then this, then this, then this, right? This way, if I make a change to x, the changes are going to reflect in the original array elements also. Now if I print the array, I am going to get the double 20, 40, 60, 80. And this is second modified code. Here again I have used references. So what happens now, these individual strings are not copied to s. S is set in alias to individual elements one by one. And again the reason of using const is same as we had in functions. Our intention here is to use ampersand or reference for performance reasons. We are not using it for the intention of modifying the string. So we use a const to clearly specify the intentions, make the code more readable, and avoid unintentional changes to the strings.